So far, we've only encountered situations where we're trying to calculate the limit of a specific number, of a discrete value. However, we could also have situations where we're calculating the limit of a non-discrete value, like infinity or negative infinity. So let's look at some of those situations now. A quick technical point on my charts that are about to become much more important is that, technically speaking, when you have a chart with an undefined point, you should call that out specifically. So all of the charts that we've been looking at so far with respect to limits are ones that I created in NumPy, as you've seen. And yeah, it just seemed too tricky to try to get these undefined points included in the graphs. But technically speaking, at the point where it's impossible to make a calculation, where the function is not continuous, so in this function that we've already been looking at in a couple of topics earlier, we can't calculate exactly where x is equal to 1. And at that point then, you should have this notation in your graph, this hollow point, to indicate that the point is undefined. So something you should be doing, but that I haven't been doing and I won't be doing because it just seemed like a pain to figure out in NumPy. All right, and that point about my NumPy charts was especially important here at this juncture because now that we're talking about infinity, I again have these quirks happening with the quick and easy way that we're using to create these NumPy charts. So for this function here, 25 divided by x, it looks like this. The function looks like this, except that there shouldn't be this vertical line here. So really, this function is composed of two separate components. So it has this curve here, and separately it has this curve here. But they're not actually connected by this vertical line. That's just a quirk of how we're plotting. So speaking of this function, it is pretty common for limits to approach infinity as opposed to a discrete value. And this is an example of one. So if we wanted to calculate what y is equal to as x approaches infinity, we can do that. And let's jump into a hands-on code demo to do it. Here is the equation from the slides, 25 divided by x, and we're trying to find what the limit is as x approaches infinity. Recall from earlier that we've previously just been working with x values that range from -10 up to 10. And that's still all that we've been plotting, and that is all that we'll plot here, but we are also here going to be assessing what it's like as x approaches infinity. So first off, just as with the other functions that we've worked with so far, I'm going to create a specific Python function for representing the mathematical function. So here's my infinity function, and you can see it's just 25 divided by x. So we can pass in our x over the range of -10 to 10, and we'll use that for plotting later on. But what about approaching infinity? Well, we can use some really big numbers to try to figure out what it would be like as x approaches infinity. So here, this is scientific notation, 1e3 for 1 times 10 to the power of 3, which is equal to 1,000. And so, 1,000's a reasonably big number, and when we pass that into our function here, it gives us this value 0.025. So how about a much bigger number? So 1 times 10 to the power of 6, that's 1,000,000. And with that as the input, okay, we can start to see that we're converging upon a y value of 0, because this is 2.5 times 10 to the -5. So this is starting to get very close to 0. And if you put in larger and larger values as your x inputs, you'll get y values that are closer and closer to 0. So it's clear already that for this function, 25 divided by x, as x approaches infinity, y is equal to 0. And we can see that by plotting it out. So as x approaches infinity, it's clear that y gets closer and closer and closer to 0. All right, there's your introduction to limits. Up next, I've got a few comprehension exercises to test how well you've been paying attention.